Too kind. As they said, I'm Paul Mockapetris. I'm also PVM at threatstop.com. That's my company. And I'm also Paul-Vincent Mockapetris at npa-lip6.fr. That's my French University in Paris. That's the email address. And I'm also a21.com because my house is at 21 A Street in California. So you can see at the start of it here, this is about naming and being able to create different identifiers for different uses. So I don't know, I'm sure that some of you only have one email address, but probably not very many of you. We all like to have multiple identifiers for multiple uses. And that's what the DNS is all about, is creating these identifiers. I happen to think that that caused a lot of changes in the internet structure. That's the disruption part. In the English, in the US, disruption is sort of equal parts, I think, of good change and bad change. It means big change, but some of it's good and some of it's bad. In France, it seems to be mostly bad. So I don't know if it's a dirty word in Portugal or not. But this is about changing things and making them better for the future. And security is one of our big problems these days. So we'll get to that eventually. To start off, my thesis is the DNS was the biggest disruption in the 1983 transition from the ARPANET to the TCP/IP internet. The internet, as we know it today, is based upon IP and TCP, which sends traffic from one place to another on the net. But in 1983, when we did that switch over, we also added the ability via the DNS to create names for whatever purpose you want and also to use them. So today I'm going to brag about that and how that was a good thing. Second part, and the reason I'm talking to you, is we need more disruption. We need people to go out there and make new facilities for the internet, and we need you to invent new things and make your contribution to the internet. So I'm going to try and teach you a little bit about some of the dirty tricks I use that might be useful to you in the future. But we need to continue to evolve this system because we're not nearly done. So today I'm going to talk about what is this DNS thing, a little bit about my philosophy, a couple of takes on disruption early in the internet's history and later on, and then what we might do in the future to change things, and finish up with security. So what does the DNS do? It does two miracles, one of which it lets ownership of names be distributed. So for example, Stanford University in California has to register once to get stanford.edu, and then they can create however many names they want underneath. This is a nice thing because before the DNS, if you wanted to add a computer to the network, you had to call up Stanford Research Institute in California. And today, you wouldn't get an answer right now because California isn't up yet. Okay, and they only ran from 9 to 5 US time. Well, Pacific US time. The DNS says once you've registered, you control your own configuration space, and you can do what you want. So you don't have to worry about getting in a call to California or some other place. Once you get your name, you can just take care of everything underneath it. And there's hundreds of millions of organizations that have done that to date. Equally important with this business about dividing up ownership into 100 million separate parts is the fact that if you want to use the DNS to send email to some other place, you don't look at it and go, oh, I don't know whether or not this is going to work because that's in a different continent, or they use a different currency there, or anything like that. It's all connected. When you go and look up things in the DNS, you just don't expect to run into any problems about, well, I'm crossing a border, or the alphabet's different, or whatever. It just all works. So being able to chop it up into 100 million pieces, that's one miracle. The second miracle is it looks like it's all still put together, even though it's all those tiny little separately managed pieces. It's exactly what you want. Distribute authority so people can manage their own affairs, but also allow anybody that you want to look up your information so they can communicate with you. Did you use the DNS? It's changed over time. In 1995, if you popped up a web page from the New York Times, You did one DNS lookup and said, where's the website for nytimes.com? That's it. Today, if you go to the front page of the New York Times, it probably does, 50 to 100 lookups. Why? Well, because each of those tiny little things like, the like button that you see and the ads and so forth, the front page is assembled as a mosaic from different advertisers, different people who are writing stories, different people that want to place ads, so that the modern website, particularly if you're in Facebook, has a squillion of little pieces that get put together at the last instant. That's one of the reasons why people can tailor ads. I mean, it's very frightening. Sometimes I go to look for how to fly to Lisbon. And for the last week, all I get is about ads about flying to Lisbon, because whenever I click and it's looking for says, Paul needs to see an ad here. And then all of the airlines who service Lisbon go, well, we want to make sure that he knows about us. Now, they haven't figured out that I bought my ticket on Air France as it happens like 3 weeks ago. But these ads just follow you, and that's because it's instantaneously filling up these little pieces of adware. It also means you could do an ad blocker by just saying, I don't want to download any content from that ad server. That's the way ad blockers work. So, it's made the ability to put together a lot of little pieces. Again, distribute authority, but still put it all together. The two sort of central themes of what's going on here. If you send email, it used to be that you would do one lookup that would say, okay, if I'm sending email to, let's say, pvm@threatstop.com, one of my email addresses, you would say, what's the mail server for threatstop.com? And you would hand the mail off to it. Pretty simple. Today, there's probably 30 or so lookups that get involved in doing that, and they have nothing to do with delivering the mail. What will happen is that it will go and take a look on one set of whitelists and blacklists to see whether or not this is somewhere that you want to accept mail from. You spend more lookups today deciding that something isn't spam than you do actually delivering it, because there's all of these reputation lookups that happen to see, does that look like a spammy source? Does that look like a spammy address? I'll ask a number of different sources to figure out whether or not I want to accept the mail. So it's sort of funny. Anti-spam uses up probably 20 times the amount of bandwidth that just delivering the mail. And the other thing that's kind of amusing is a message that actually gets delivered uses much more of this, because it has to have passed all of those individual checks to decide running the gauntlet of anti-spam systems. If you made a phone call, you probably used the DNS, although you didn't know it. This reminds me of this, there's this recent discovery about gravity waves, and they send a laser beam. It's like we're discovering atmospheric waves with the display moving around. But anyway, if you do a phone call, typically DNS is used between service providers to route phone calls. DNS also exposes you a lot. What do I mean by that? I have an XP machine at home, and when I open up the cover and hit the power button, before I've typed on any keys, it's tried to do a bunch of DNS lookups that I'm showing here. And the things that I've revealed are WPAD says, there's a browser on this machine. These things where it says printer, it's revealing the fact that it's looking for that particular printer, from which I've sort of revealed that, if I'm interested in the black and white printer 4 at nominum.com, I'm probably connected to nominum.com. Perhaps more concerning is download 632 from avast.com, which shows that I'm using Avast antivirus software. By the way, there's down below, somewhere in here, it's revealing the fact that I have Google add-ons. The CR tools. So all of this chatter goes on in the background where your machine, when it's powering out, is reaching up to all of these services, but you're also revealing to anybody who's watching what antivirus software you have, probably what company you belong to, what version of the software you have, on and on. This varies a little bit. So, it's an interesting facility to be able to draw together these resources at real time. but it's also going to be a question later on about what you're revealing and what the security is going to be. So I'm going to give you a little bit of my philosophy, first of all, which will kind of explain the way I thought about some of the ideas we're going to be discussing. All distributed systems have three parts today, okay? Oh, wait a second, I forgot the labels here. There's milk, there's wine, and there's a tombstone and a tax form. So there's really three parts to all distributed systems, and technically they're called hardware, software, and configuration. Why is milk hardware? It's because you want the freshest possible stuff, right? You always want the newest stuff. You want it, as quickly as you can get it from the cow to you. That's the way you want to go. Wine, gets a little bit better with age. You make it, and if you let it sit around for a while, it gets better. Software is kind of like that. You don't want to be the first guy to run the new release of the software. You'd really like to let somebody else figure out what all the initial bugs are. So it gets better with age up to a point. So software is like that. Configuration, that's death and taxes. It means stuff that you're forced to do, you don't want to do, but you have to do it, all right? And that's the part of the thing, of the problem that DNS was meant to make easier for you, again, is being able to configure that and be able to change the hardware as fast as you want to and be able to deal with the needs of the software. Why is it always so messy? People always complain about, oh my God, I don't understand my network anymore. I don't understand security. I don't understand the routing, blah, blah, blah. It's because we're always, first of all, fleeing from the competitor. This is American football, so it's probably a bad analogy. But the guy on the right wants to catch the ball, and the guy on the left wants to make sure that that doesn't happen. You always have competition. So the reason that the ball is thrown so far in advance and so forth to make it difficult for him to catch is to avoid the competition. And that's like adding complexity to what you're doing. If that guy on the left would just get out of the way, they could throw the ball and make it catch much more easily. But you're always dealing with, you have to have competition, and you have to have a certain amount of complexity to help you deal with it. But you want to reduce that as much as you can. So priority one is always reducing the complexity when you can. I think the third principle that I have is simple ideas win, but may take time. So we have our cavemen here. I'm sorry this is kind of washed out. But the difference is there are these three cavemen over here that have discovered fire is a great way to cook meat. So they each have their pieces of meat, and they're holding it in the fire. There's a simple add-on invention that the guy on the right has, which he says, oh, I'm just going to put my meat on the stick instead of holding it in the fire with my hand. The simple ideas win. So when people tell you that in order to innovate or disrupt in the internet, you have to come up with big, complicated ideas, I don't think that's so. Another set of examples is if we take a look at air travel. Everybody flies around these days. It took 40 years to go from the first commercial flight, which was on a Zeppelin, an inflated balloon, to a jet airliner. 40 years. And that's all very complicated engineering because you had to get rid of the balloon and put propellers on and make a motor light and all that kind of stuff. 40 years it took to do that innovation. A similar innovation took place in luggage. It was 40 years from the invention of the airliner till people figured out, well, gee, if I have a wheelie bag, it's easier to take it onto the airplane. That took 40 years before the guy who invented that did it. So sometimes these simple ideas are out there just waiting for us to come up with them. So let me talk a little bit about how do we first disrupt. I'm going to go through the history of the DNS. So the history of the DNS says the IETF published these RFCs in 1983 that made the DNS. Okay, that's pretty simple. That's in Wikipedia. You could check it. It must be true. The first IETF meeting was held in 1986. So that was pretty cool, right? Because they published their RFCs 3 years before their first meeting. And then they also say that the ARPANET on which they did it the first time was turned off in 1983. So, the history here has gotten a little bit mixed up. So I'm going to tell you the real story. The traditional story about where the DNS came from was John Postel, who was my boss at the time, and this is true, came to me one day and said, we need something new. because this host table, which was this one file that had a list of all of the machines that were connected to the network. Well, we're not really sure we can do that, and we got this 9 to 5 problem, you know. And besides, there's all of these people who have come up with new approaches that they want to have, and there's 5 of them. So Paul, we want you to go figure out how to make a compromise between these 5 proposals. Now, a lot of people say, Paul, how did you ever get the job of creating the DNS? Because that's like, wow, you know? You must, I mean, how did you get that job? The answer was, at the time, nobody thought it was important, okay? That's it. Nobody thought it was important. They said, oh, that's a nice little problem for this new graduate. We'll give it to him. They were all doing important things, like trying to figure out how to send, you know, those punch card images over TCP connections. That was a big deal at the time. There was a bunch of stuff like that. So the reason I got this job was, first of all, they figured out that seeing as 5 professors had 5 different proposals about how to solve this problem, that they must be close to done. And all I had to do was kind of glue it all together. Okay. And probably what I would do is I would turn what was kind of a tent like host.txt into something that was sort of like a parking structure. Still another place where you would just store stuff all in one place. Okay. So that started out. So, you know, at the time, the rules for kind of disruption were you convinced ARPA or some government agency that you had a good idea. You got money and permission from them. You do good stuff, and if it turns out to be appreciated, then you go back to step 1 and get more money. That was the way people built the original TCP, IP, and all of the internet protocols and so forth. If you notice that, ARPA is often too busy to watch what you're doing. And in particular, this nice little problem that's being given to this grad student, well, we don't have to supervise grad students. We just let them kind of come back when they're done. So I just kind of got to do whatever I wanted. It was good. Whoops, sorry. So where the DNS's ideas really originated were from my experiences before I got this job. I worked on virtual machine technology at the very earliest time. I just happened to get a job at IBM so I could eat when I was going to college. I thought it was nice to do that. I worked at the media lab for a while, and the media lab wasn't important. So they couldn't get big machines. Nobody would give them big computers, so they would only give them little mini computers. But Nicholas Negroponte, you may have heard of him in the MIT Media Lab, you know, he would go around and get a lot of little computers, and then he said, okay, Paul and you other guys, figure out how to glue them all together. So we were building distributed systems to help architects design buildings, but we didn't know we were doing computer research. We just knew that all we had were these little machines, and we might as well glue them together. So again, this whole idea about building distributed systems came to me kind of there. One of the things that people always say is, well, why didn't you use some fixed levels of hierarchy? You know, why don't domain names only have 2 parts? You know, only allow 1 dot, or maybe 3, or any fixed number. And I said, oh, that caused me headaches when I was doing it at the ARCBAC, so I will never do that again. I also built some spacecraft. Spacecraft are kind of interesting because when you shoot them off, you typically can't get there to repair them. Now and then you can, but building things that are reliable kind of. So there was just this DNA in my experience that was completely different from the way that people wanted to do things. But that dictated my approach to the DNS. So, you know, the original rules were build something that's as complicated as it can be and still get off the ground, which meant it had to be pretty simple. You may have read about how the DNS has a design flaw, about how it didn't, you know, the security didn't work from the original design. Well, I can tell you, the reason it didn't work, it was like a house where not only did it not have locks, it didn't even have doorknobs. It didn't even have doors. We left the security out. We did it on purpose. Because if you go back and read the description of the times, people were saying, oh my God, this thing that Paul's done, it's all distributed and it's much too complicated. They thought it was much too complicated to start with. And that's after we left out security and a bunch of the other stuff. But 5 years later, they wanted more. So that was my definition of success. But the key values here, I think, were that it had to be simple and understandable. And so that was the purpose. And a lot of things got purposely left out. And I don't apologize for that. If I had tried to build the complicated thing from the start, it would have never gotten off the ground. And we would have been reading about how somebody made a simple DNS or something like that. Okay, so what happened? I basically wrote these basic protocols, sort of the basement of the cathedral, if you will. And that's the basis of the DNS that we have today. So I like to tell people I built the basement and maybe the first 2 floors of the DNS. And since then, people have added about 50 stories. There's all of this other stuff that's been added on since then. And I'm very proud of that, even though it's been done by a bunch of other people. This is a diagram about the different documents about if you wanted to go learn all about the DNS and you want to learn everything about it, you would go get RFCs, which are these documents that are done by the IETF. And each of those little blobs there is a separate document. These 2 green ones here are me. And then all this other stuff was built on top. So there's about 100 pages of DNS that I wrote. And there's somewhere around, I think it's 5,000 or 6,000 pages of add-ons that other people have built on top of it. So the message, I think, here is that if you wanted to try and do something really interesting, you can't do it all yourself. What you want to do is to build a base that other people can build on top of, just like the people that made the original web. The original web wasn't anything like it is today, but it was a basis on which people can build. The way to create disruption is to build something where other people will build on top of what you have. Now, this is a little bit like having children. And what that means is sometimes your children don't do what you want, right? Most of you are in the stage of not doing what your parents want just yet. But sooner or later, you'll get to learn the other side of it. Yeah, there's parts of it that I don't really like. And if there's those 50 floors on top of my original design, 435 really. But that's just the way it is. Enabling people and having a generative technology is, I think, the key idea. Planned disruption ends. This just goes to show that I'm not always right. So in 1989, ARPA told me, we're not going to give you more money to do DNS stuff, Paul, because we only do innovative breakthrough technologies. And I said, well, but there's all this other stuff we could do, like, I want to build the 3rd floor. What do you say? And they go, no. We only build basements and 1st floors. We're not going to let you. So I said, okay, I'll go over to the National Science Foundation in the US, and I'll propose some additional work to do for the DNS. So I proposed to fix bind. For those of you that may have worked in this area, bind is some open source software that implements the DNS, which as far as I can tell is never debugged. There's always bugs in it. But I wanted to do some other stuff, which is add security to the DNS. And then I said, I also have this other idea. What we'll do is that we'll use this configuration database, we'll crawl the web, and we'll build an index of all the hosts and stuff on the net. And they said, no, Paul, nobody can crawl the whole internet. I mean, it has thousands of hosts. Well, at any rate, it's a good thing the Google people didn't have the same sponsors. But basically, they told me that a bunch of stuff I wanted to do was impossible. And furthermore, they said that abuse of the system was not going to ever be a problem. I don't know whether or not you've been reading about the 10 gigabit denial of service attacks that are out there commonly, and about how people use DNS denial of service, when they're basically playing competitive Counter-Strike to slow down their opponents. But, all of this stuff, they said, oh no, will never happen. So that was a problem for me, but I sent in my proposal. And the reviewers, the first reviewer said, excellent. The second said, very good, but it's not really research. It's not like, this is not science, this is engineering or something. And the third one said, very good, but can you just fix the open source software instead? Now, I'm sorry. Any of you that have written proposals or reviewed them know that you never say, this is stupid and I don't believe it. You say, well, it's very good, but there may be excellent stuff somewhere. So very good is the kiss of death. So NSF decided they couldn't decide whether or not to fund it, and nothing happened. So today, how do you disrupt after 1990? Instead of going to the National Science Foundation or your university, you build an ARC. No, I'm sorry, you go to a venture capitalist and you say, hi, I have a cool idea, can I get some money? And then maybe you get the money, you do stuff, and you earn more money, and life is good. So the disruption that we saw kind of after 1990 wasn't any of this kind of researchy, government-based stuff. It was all stuff like, one of my favorites is that ICANN, which is the organization that's giving away these new top-level domains, like now you can have a top-level domain that, in addition to .com, you can have .paris. They have one that's .kosher, for those of you that want to have kosher websites. I was very surprised because I didn't think that the disputes between the different religious levels of being kosher would ever be settled, but they were. But we can't decide about how to have .vin for wine because the French are insisting that you can only register names that follow the French appellation rules. So, things like California, Champagne. No. Champagne only comes from France. People can't decide about how to have these rules for naming. But how much money do you think ICANN got in order to decide how to create 1,500 of these new ones? They got over $350 million. That's 300 million in application fees alone. Very bizarre. There's certainly a lot of money in this naming stuff. And that was just kind of the tip of the iceberg. So I wonder whether DNS has turned into DN $. But certainly there's a lot of people that have been working about making money in it. I try to be some of them. One of the things I think is really interesting is DNS has been fantastically great at creating PhD theses. I did a Google search for domain name system PhD thesis, and I got 1,420,000 hits. Whereas if I did it for transmission TCP or IP, I got less. It's amazing because people just love it because you can observe what's going on and write a thesis about what it all means. And it's been amazingly successful at that. Again, remember we said before that when you turn on the machine, there's all these requests and you can learn stuff. And so people have been spending a lot of time doing just that. Whoops, stop that. A less successful thing was we tried to use the DNS to do RFID. RFID are those tags that you can put on cars so that you can go through gates on the freeway and you get charged automatically. Every cow in North America has its own RFID tag, and customer products do. So you can put these tags on things and read them remotely. I think passports now have them as well, which might or might not be a good thing. So some people at MIT got the idea that what we needed to do, this is the Auto ID Center, we need to be able to associate names with all of those so that we can look up what the information is associated with a particular cow or whatever. So they came up with the standard for doing that. And then they turned it over to EPC Global, which is this organization that regulates, for example, barcodes, those stripy codes on the side of packages. Okay, so that was all good, except for the fact that the MIT people had defined a standard where you had a 96-bit number that was the unique ID. And what they did with that is in order to chop it apart, those of you that have looked at the way addressing works in the internet, is you can chop off a certain number of bits to build up a hierarchy of subfields. The EPC Global people said, no, that will never work. And the MIT people raised their hand and said, well, actually, the whole internet works this way. Everything that has an internet address works this way. So we've done it before, and there's millions of them out there. And EPC said, nope, too complicated, won't ever work. So they decided that instead of having different numbering systems for, say, cows and, say, tanks, because NATO has a numbering system for tanks where they have an RFID tag on the side of the tank. You know, and you have many more cows than tanks, so you can use fewer bits and a smaller number of identifiers. But they said, no, we have to standardize, and there's only one format. So why did that happen? My theory is that it happened because people that were already in that business with barcodes didn't want anything good to happen with a new technology. So the real world intrudes. The IETF also said, let's use the DNS to register phone numbers, and we can use it to route phone calls. That standard never really worked either. And the reason for that was that the people who make the boxes of equipment that they sell to telephone companies to route phone calls don't really want an open standard that makes it easy for everybody to interoperate. They want to be able to sell more of their own boxes. So the lesson here is when you want to disrupt, you have to realize that people that already have a business in that area may not like your idea about figuring out how to suck all the value out. And if you want an example, you could go talk to your local Uber driver here in Lisbon who's going to say, oh, you want to go to the airport? No, I don't think so. My taxi friends are waiting for me at the airport, and I don't want to go. I mean, the same thing happens with all of these ideas. If you want to disrupt, you have to pay some attention about people that already have business interests there. So I think when we take a look at all of this, the last thing that's different is that the rules change over time. Yesterday, it was great that the DNS used datagrams because they're fast. Today, it's a problem because there's DDoS attacks. The rules change as the people that are using your system change. So you have to be willing to figure out that the way you build your system may have to evolve over time. So what do we do in the future? One of the ways I think you could think about disrupting the existing DNS, yeah, that's right. I'm saying maybe you want to replace my baby because the real thing is that technology doesn't last forever. If you want to try and do something and be remembered 200 years from now, I'd suggest you try music. Well, I think Mozart will still be around in 200 years. I don't think the DNS will be. Technology always gets replaced. So what do we do here? One of the inherent flaws in the technology that I built was I built it so it was lightweight enough, so the plane would get off the ground. It didn't have these features. And it didn't have good security. People have tried to retrofit security onto the DNS, and it hasn't been so red hot. It may be that the next time that people come around and reinvent this technology, they'll take security as being the starting point of it all. People have come up with a new set of schemes. They've invented the fact that you should use naming in order to do data. They call it information-centric networks or name-based networking or pub-sub or about 8 different things. The one thing that they agree on is that naming is the important part of the architecture. The one thing they disagree on is what their work should be called. But this stuff is already going on. And it's one of the perhaps things that's going to come and build a better DNS. But the information-centric networking people have their own set of issues. They're trying to build a system that requires you to replace everything. And what I mean by that is those of you that have heard about IP version 6 replacing version 4 and how that's taking forever, that's because replacing a whole set of stuff that already works is inherently something that's going to take forever, and you can't deploy it as incrementally as you think. So that's always a problem with disruption. Those of you that have been out there and have heard of Bitcoin, I don't know, everybody here has heard of Bitcoin, right? It's kind of cool, like there is no central authority, right? And there's shared databases that everybody has to have, and there's the blockchain and so forth. But there's not necessarily the central management. There's not necessarily an ICANN sitting in Marina del Rey taking in $1/3 of $1 billion in order to hand out names. Maybe what we should do is just replace a bunch of this network configuration management with something that's based upon blockchain kind of technology and has no central authority. People have already done it with a system called Namecoin. But unfortunately, that turns out to be a scam. What they did is they said, okay, we're going to create a system where anybody that wants to can register a name and have it, and it's just purely first come, first serve. And anybody that wants to can join. And oh, by the way, we already registered the first billion good names. They don't tell you that part. But I mean, this kind of technology and applying it to the management of the internet, I think is one of the great things. Getting people out of the loop and remember that death and taxes, getting rid of configuration? I think this is one of the great places to think about disrupting in the future. So then, at any rate, the goals there would be to create a set of distributed algorithms that don't require all of this personal management and all of this, well, does California law apply or not? All of these political issues that we get in internet management today. So I'm going to talk about security here to kind of wind up. If we take a look at the history of the DNS, we started off in '83 with the RFCs that defined the DNS, and 3 years later we had systems running in production. Okay, so that seemed like at the time that seemed like just terribly slow progress to me. But by today's rules, it seems sort of lightning fast. In '89, I saw the first case of cache poisoning. That's where false data is getting into the DNS somehow. And today, it may be by malicious people. And in '92, people started this DNSSEC thing. Now, the interesting thing is it took us 3 years to launch the DNS, but we went to add security starting in '92. We're like maybe half done today. I mean, it's not deployed over half of the internet. And people have all of these issues about doing it. So certainly progress there has been slow. Amplification attacks. How does an amplification attack? This is one of the big criminal uses of the DNS. And it has to do not with looking up data, but like I said, people who are playing Counter-Strike send DDoS attacks against their opponents so their network slows down. And it's just the idea that you just send a bunch of junk at a particular destination just to clog it up with packets so that it slows down or fails. Why is the DNS good for this? Well, it starts off by you send a simple query, like you might send a query to isc.org saying, hey, tell me what your address is or any other information. Whoops. And the reason it's an amplification attack is that a very small query gets a very large result. So this is the result you get if you send that query. The query started out being about 64 characters, and the response is this long. So the way the attack works, two different ways, one of which is you over here forge a packet. You forge the source address here, and you send a query off to the ISC server saying, send me that big packet. And oh, by the way, I'm Spamhaus. Now, that packet didn't really come from Spamhaus, but because you put Spamhaus's address on it, the response goes to Spamhaus. So, you know, if you wanted to try and be mean to Spamhaus, you could send them a big packet. But it's much more effective to bounce a 40-byte packet off of somebody else's server and get a 2,000 character response sent at it, so that there's this amplification. So that's the way people get these gigabit flows. And interestingly enough, when you start thinking about using DNS security, what happens? Well, you put a big digital signature on top of the data. In fact, the signature is much bigger than the data itself. You know, I'm sure you've seen these pictures of Paris bridges where a huge bridge has tens of thousands of little locks. Okay, but in the DNS world, it's the other way around. The data that's associated with it is a few bytes, and the lock is like 50 bytes long. So turning on security means that it's easier to do these denial of service attacks where you just throw a bunch of junk at a destination. So
you can always prevent the source address to be sent outside your network, right?
Yeah. Yeah. Oh, okay. Ah, gee, that's the trouble with talking on Friday. People have given your talk on Monday. All right, I'm sorry. Let me go faster. Paul Vixie didn't tell you this. So what we actually have in the internet today is the situation where we have some old methods for dealing with security, these two lower graphs, but the threat level is rapidly overtaking them. And we haven't figured out yet how to transition to the DNSSEC era. So the security of this thing is getting rapidly worse, particularly seeing as these attacks for DDoS and these forging attacks where you put false information in the system all get easier the faster your network goes. So it's easier to attack a DNS server in a 10 gigabit network than it is to attack one in a 1 gigabit network. Speed is actually an advantage here, because if you only have one chance in 4 billion of successfully fooling a bind server today, okay, gee, that sounds pretty secure, but not in a world where I can send 4 billion packets in an hour or in 10 minutes or whatever. So all of these statistical attacks mean that as the network gets faster, it gets less secure. Very odd thing. I don't know, Paul probably didn't say that part, I bet. He likes to avoid that part. At any rate, a second lesson here, and this is from Japan. The people in Japan decided when these DNS problems came out that they would do a big effort in order to make sure that their systems weren't infected. And these two lines here represent the vulnerable systems and the systems that have been patched. And I think the point is that after this big, huge effort, they still ended up with 20% of their systems that weren't patched at all. When you think about doing security here, you've got to assume that a large chunk of the internet is not secure, and in fact may well be infected. How do bots work? Bots typically have these 4 phases where you get a free coupon or you get to watch pornography or something. You go and look at something on the web that you really shouldn't. And when you do that, step 2 happens. The bad site infects you with a malware. And then step 3 is the command and control center says, oh, go steal money from your user, or go encrypt all his files to ransom them, or help me out in a DDoS attack, or whatever it is. And lastly, the bad stuff happens, step 4. So the question is, what can we do about that? And what you'd really like to do is you say, well, okay, there's these 4 different things. I could try and just stop one of them. But it's probably best if I could think about an approach where I try and interfere with each of those 4 distinct activities to stop the infection. But if I can't stop the infection, stop it from harming others, that kind of thing. So how do I do that? Well, one of the simple ways to do that is to notice that all of your attacks are going through either your routers or your firewall. It's kind of interesting here that you provide the infrastructure that the bad guy uses to attack you. All right, so what should you do about that? Well, one of the things we do at ThreatStop is we just say, hey, we should tell your firewalls and your routers who the bad guys are so that when they see that traffic, you just drop it on the floor. You say, well, but the problem is the bad guys changes their domain names very quickly. Paul told you all about that, right? Okay, but we download new configurations quickly too. So I think the thing to do is the first line of defense here is you got to think that the way you should handle your internet traffic is a little bit like the way you handle your email. You have lists of good guys and you have lists of bad guys, and you want to just drop that traffic right away. You don't want to say, okay, I'll go accept this big, huge, poisoned, Excel spreadsheet, and then I'll try and see whether my email server can analyze it. You want to go, oh, this is coming from Bulgaria, and I sell vegetables in California. No, I'll just geo-block that traffic. Or it's coming from a particular set of sites that we know is bad. What we'd like to do is to try and figure out how in the future, when you come in the morning and pop up that web page that says, oh, there's this new attack and it's terrible and these servers are involved, that during the night we downloaded new configuration information that said don't talk to them already, and it's done. Because there's lots of people that have their sysadmins come in every morning and go look at the latest threat data and reprogram all of their routers one by one. But the bad guys will typically try and attack when those sysadmins are asleep. So, being able to have an automatic process for doing it is kind of the grail that we're pursuing. And, in order to do this, you need to do a number of steps. The first is to collect some threat intelligence. And Paul probably told you about SIE and the way he's collecting threat intelligence, and we use his stuff. Then you have to go and combine that with the priorities and desires of your own site. It could be that you have some geo-blocking kind of thing where you say, well, my business is just selling Portuguese flags in Portugal, so I just want to talk to people in Portugal and geo-block everything else. That might make sense. It wouldn't make sense for Amazon, but if you can do that and if you can cut the bad traffic down, that's the good way to do it. Distribute it to all of the devices that are handling your traffic, like all the routers and firewalls. We happen to use the DNS for that because, well, I think it's cool. And because the DNS goes everywhere. There isn't a device that connects to the internet that really doesn't know how to do DNS. So that way we can make sure that we can distribute to whatever devices you want. And the other part that we haven't gotten to yet, but is a challenge you guys might think about, is after you've programmed your firewalls and all this stuff to stop the bad traffic, what you really want to do is take a look at all the traffic that you've stopped and see if there's patterns you can use to improve your security algorithms. Analyze your logs, and perhaps share that log information with other people. So one of the big things, and Paul, I'm sure, talked about this, the other Paul, is passive DNS, so I'll let that pass. And then, lastly, you got to figure out how to automatically correlate that information about known bad addresses with known bad domain names and so forth in order to get the right security posture. We're in the business of outsourcing that computation for you. You can either do it yourself or you can hire somebody to do it. What about public DNS services? Because that's one of the things people say, oh, well, I don't have to worry about all of this. I'll just use Google DNS. Or I'll use OpenDNS. Or I don't know, how many more of them? Is there more of them in Portugal? At any rate, there's a bunch of them out there. So what they do is they provide you with free DNS service. And I love it. Google promises that they won't look at what you're doing. They won't keep your data for more than 48 hours. So they preserve your privacy. Now, you remember, these are the same people that select what ads to insert in your web page on the basis of a millisecond or so, right? In 48 hours, they're probably pretty done analyzing stuff, I would assume. The question you have about a lot of these is, do you have to worry about your personal information? Because it probably wasn't so bad to know what my printers were and so forth, but if we're watching what websites I'm going to, do you care about that? And a lot of people tell me, oh, well, I use those services because they're faster. They usually aren't. What's usually happening is by putting any explicit addresses into your configuration file, it's better than having your local Belkin router. There's all of these access points, and they say, we're going to help your DNS service. And if you do anything to put explicit addresses in your computer to avoid what's in that Belkin router, you get better performance. So very often it's just a question of you bought an access point that doesn't know how to do DNS and it's trying to help you. I got in a lot of trouble because when I wrote the original article about that, it came out as Paul says Belgians are ruining the DNS. And I just want to make sure that you understand that was an autocorrect spelling thing, not any Belkin going to Belgians. All right. How do we prevent the user from going to bad places? There's a lot of governments that want to do that to prevent you from going to places that they think are wrong. In Italy, it's no child porn and no gambling sites that aren't paying their taxes. Other gambling sites are okay. I think that my view on this is that you should be able to choose the policy that you like if you want to edit out. For example, I don't want to hear about Donald Trump, so I'd prefer that all those websites go away. I don't want to hear about Hillary Clinton. I don't want to hear about most of my politicians. If you want to do that kind of stuff, that's fine. But you should be the one that chooses, probably not your government. But one of the key messages is that everybody is doing the editing of the DNS and using the naming to control where they go. So typically now you got to look to your ISP or your enterprise to do it. Having this kind of censorship isn't all bad. For example, the fact that they had free Wi-Fi in the London Tube during the Olympics was due to the fact that Virgin could give away free Wi-Fi, but not if people would be looking at pornography in the subway. Very strange. So sometimes it's just easier to say, okay, we'll filter out the addresses. And oh, by the way, most people who have jailbroken their phones can go to a different DNS server anyways, but you know, don't worry about it. In the enterprise, I think this is particularly important. Enterprises are typically the target for more cyber espionage and other kinds of attacks. So you know, they should be able to use the DNS to program their firewalls and so forth to get it done quickly. Realistically, this is just the first line of defense. But what it can do is it can cut the amount of work that your email servers and firewalls and so forth have to do doing detailed analysis of content back by a factor of 4. They have much less stuff. You can set it to be more sensitive by just throwing away a lot of the garbage at the edge of the network. And oh, by the way, you may get 10 or 25% of your network bandwidth back because you're spending an awful lot of your network bandwidth carrying stuff that you really are going to eventually throw away. So why not throw it away earlier? So, at any rate, security gets kind of boring, and I put it at the end to try and tell you the interesting stuff, but I think security is the grand challenge that we all face. I talked about a particular set of problems, but in reality, if we want to keep enjoying the internet in the future, we have to figure out how to make it a little bit safer. I think anybody that listened to the other Paul's talk, or I was particularly taken by the hacking the home Internet of Things talk yesterday. It's something we need to do, and we need to pay some price there. So thank you very much. You've been a great audience. I want to thank the SINFO people. They're great. They're all volunteers. I don't understand why more of their professors don't come to the talks. It looks like it's all students, but oh well. So thank you very much.
So thank you very much, Paul. I don't know if anyone has any questions. All right.
Good afternoon. My question is about these conflicts of interests that already are around DNS, you know, the governments and people want not to be censored by the governments and, you know, companies and monetary issues. You talked about maybe a future thing that could replace DNS, something that was not centralized. How do you prevent something new that is not built by source by these conflicts of interest? I mean, we're fighting today to have an open internet and secure internet, but the institutions that are in charge are a stake that want to defend on these issues. How can we make sure that the thing that comes next won't be, you know, poisoned by some of these interests?
Yeah, well, I mean, part of the problem is that usually about half of the audience has different interests from the other half of the audience here. You know, my view is that first of all, you should have open standards for most of this stuff, and that I'm not a complete open source person. In the sense that a bunch of the open source stuff, I once tried to do a study about whether proprietary software had a better history of being secure than open source. And after looking at that, it appears to me that it's kind of a push. Because what happens is in the open source world, people look for security vulnerabilities in all the interesting places. People who are attacking it look for the vulnerabilities in the places where they haven't looked. So just recently with this Unix library stuff, there's this library code that was really pretty was a pretty lousy piece of code, and it allows buffer overflows, and it's been in place for like 10 years. You know, people say open source is audited. Well, it doesn't appear that this stuff was ever looked at. You know, Apple is trying to sell security as part of the added value of its product. We'll see how the government works in letting them do that. In that particular case, I'm more worried about whether or not companies like Apple can build software that they can't themselves break into than whether or not that specific case gets scheduled one way or another. I think it would be a mistake to require that every piece of hardware be open to government inspection all the time. But that's my politics. And we're in Portugal, and I have no advice for the Portuguese. I only have advice for my friends back in the US, and I think Apple should be able to make software that, make devices that it can't open. But that's me. I'm sorry, that's kind of vague, but I think that Apple is not open. It's a proprietary approach, but they seem to be giving me more security than anybody else.
Any more questions?
Hello. What do you think that will be the lifespan of DNS? Do you think that the next big thing for the internet will come very shortly or in a long time? Because DNS is from the 80s, so in terms of technology, it's a bit old. Even though
this is just a guess. But I think that what has to happen is, when we talked about the RFID tag technology and we talked about the enum technology, the problem DNS 2.0 has, its biggest problem is DNS 1, because it has to figure out how to displace it. So it has to come with some unique set of features or some unique capabilities. I think a better security model might be it. I think a model that lets anybody get a name that they can use in the internet without having to register with, VeriSign and all these registries and all these other guys that just seem to want to centralize authority and make money. It might be a way to go do it. But you guys are supposed to be the next generation, and you're supposed to figure out the answer to the question, not me. I want people to tell me I'm famous and my system is great for a longer period. You're the guy that wants to invent 2.0. Anybody else?
So no further questions, right?
All right.
All right, let's give a big round of applause for Paul Mockapetris.
Thank you.
Thank you, Paul.